Representing proportional relationships with equations. So we're going to be doing K times X equals Y. Students use the concept of proportionality to represent proportional relationships in equations in real-world contexts as they relate the equations to a corresponding ratio table or graphical representation. Points to remember: proportional relationships have a constant ratio or unit rate, which is your Y divided by X equals your K. And that K is also known as your constant of proportionality. Do we have enough gas to get to the gas station? Your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating that there is a half gallon of gas left. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table to determine whether you will make it to the gas station before the car runs out of gas. You know that you can determine the amount of gas that her car consumes in a particular number of miles when you can determine whether or not you can make it to the next gas station. So find the constant proportionality in this situation. So if I take the gallons and the miles driven, and I take this is my X, this is my Y. So if I take my Y divided by my X, I get 224 divided by 8, 280 divided by 10, and 112 divided by 4, which gives me a K of 28. So the constant proportionality is 28, and the car travels 28 miles for every 1 gallon of gas. Write an equation that will relate the miles driven to the number of gallons of gas. So we're going to keep using the same generic equation, Y equals K times X. X is our gallon, and Y is our miles driven. We know that the K is 28. We found that up here. So I'm going to use M for Y and G for X. So I put it more in the context, and it's miles equals 28 gallons per mile. So knowing that there's a half gallon of gas left when the light comes on, will she make it to the nearest gas station? So a half a gallon needs to go in for the G. So I'm going to have M equals 28G, M equals 28 times 0.5, the half gallon. So that's going to be 14. So since the gas station is 26 miles away, no, because it's 26 miles away and she can only go 14 miles. Using the equation you found in part B, determine how far your mother can go on 18 gallons of gas. So 18 gallons of gas, again, that goes in for the X. So I just multiply together. I get M equals 504. You have to use the equation. That is a must. Using the equation you found in part B, determine how many gallons of gas would be needed to drive 750 miles. Since this is our Y, I plug it in for our M right here. So 750 equals 28G. Divide each side by 28. I get 26.8 gallons. So almost 27 gallons to go 750 miles. Andrea's portraits. Andrea is a street artist in New Orleans. She draws caricatures, cartoon-like portraits for tourists. People have their portrait drawn and then they come back later to pick it up. The graph below shows the relationship between the number of portraits she draws and the amount of time in hours needed to draw the portraits. Write several ordered pairs from the graph and explain what it means in the context of the situation. So I'm going to look at my line real quick. And if I look nice, it intersects there nice, it intersects there nice, and it intersects there nice. So we have 2 and 3, 4 and 6, 6 and 9. So 4, 6, remember it's X comma Y, means there's 4 hours, she can draw 6 portraits. 6-9 means in 6 hours she can draw 9 portraits, and 2-3 means in 2 hours she can draw 3 portraits. Write several equations to write the number of portraits drawn to the time spent. So if I'm just going to do my y divided by my x, I can do it just like that. So it's really going to look like y equals y over x times x. So my y over x, so I have y equals 9 over 6x. If I divide this, I get 1.5. So y equals 1.5x. If you notice, they're all the same thing. Determine the constant of proportionality and explain what it means in the situation. The constant of proportionality is 3 over 2, which means that Andrea can draw 3 portraits in 2 hours, or can complete 1.5 portraits in an hour.